Hello, my name is Nimit Gandhi, and today I'm here to talk to you about my research regarding single-walled carbon nanotubes, silicon-based solar cells. Within the past 25 years, there's been a push to find an alternative energy source to replace fossil fuels. At the forefront of all of these possibilities lies solar energy. My research design incorporates a silicon substrate and single-walled carbon nanotubes. But what are single-walled carbon nanotubes, and why are they beneficial in solar cell research? Well, single-walled carbon nanotubes are single sheets of carbon atoms rolled into cylindrical tubes. Single-walled carbon nanotubes are beneficial in solar cell research because of their ability to absorb a larger part of the solar spectrum than silicon can. While silicon can only absorb light in the visible region, single-walled carbon nanotubes can absorb light from the infrared and ultraviolet regions as well. My research design incorporates a nitric acid treatment atop my single-walled carbon nanotubes. I hypothesized that applying this nitric acid treatment to my devices would help to increase the overall efficiency of the devices, because the nitric acid would remove any free electrons within the single-walled carbon nanotubes. This is an important property because these free electrons can impede the flow of the other electrons, thus reducing the current and the overall efficiency of the devices. To test my hypothesis, I obtained a silicon wafer and deposited silicon dioxide, titanium, and a gold electrode. Meanwhile, single-walled carbon nanotubes were purchased and underwent various purification processes to remove any impurities. The single-walled carbon nanotubes were then placed in a deionized water solution and were passed through a filtration system. In the middle of this filtration system was a film. The film was permeable to the water, but because the single-walled carbon nanotubes were too large, they were impermeable and thus stuck to the film, creating single-walled carbon nanotube films. These films were then lifted onto the silicon substrate to create the devices. After applying the nitric acid treatment, I was able to conclude that the nitric acid helped to increase the efficiency of the devices by over 90%, thus supporting the original hypothesis that I had mentioned. This groundbreaking research has prolific implications for human society. Nanomaterials have been used in the solar cell industry for a couple of years now, and they are responsible for establishing the world's most efficient solar cell at 44.2%. Additionally, the incorporation of nanomaterials such as single-walled carbon nanotubes versus a silicon solar cell means that these newer solar cells are more efficient, less expensive, more lightweight, and have less environmental degradation. These are the reasons that this is a feasible opportunity to transition towards an alternative energy source. Thank you.